Hello, my name is Piper Horning. I worked in Lake House's lab this summer, mostly with Victor Blanco, and we were measuring the stem water potential for water conservation. So right off the bat, what is stem water potential? This is a direct measurement of water tension within the plant and is given in metric units of pressure. The stem water potential is important for growers so that they can analyze what the environmental effect has on plant growth as well as plant stress, but also so that we can find a middle ground to conserving water while not overstressing the tree. So our project took place at the Smart Orchard in Grandview, Washington, and our goal was to collect the stem water potential using two different methods so that we could compare the reliability of each method and then use the data that we collected to compare with environmental factors. The two methods that we used was one, installing microtensiometer sensors into the tree trunks. So the picture at the bottom, that is the sensor installed directly into the tree trunk. And then the second method that we used was a pressure chamber, and that is shown at the picture above. This is a map of the orchard in Grandview, and as you can see, I have two sites labeled, and this orchard has a pretty big slope to it, and so these sites are spread out across the orchard so we get some variability in our data. And at each site, we installed two microtensiometer sensors into two trees, and then every 7 to 10 days, we would go down with the pressure chamber and measure the stem water potential at all four of those trees. So comparing the microtensiometer to the pressure chamber, the microtensiometer is a sensor that we install directly into the tree trunk, and this just shows us the expansion of the trunk due to water retention. This was about a 20-minute installation per tree, and we did this at the beginning of the growing season. But once it was installed, it started collecting data every 20 minutes. One downside to the microtensiometers is that we could only install 4 in this orchard because they are quite a bit more expensive than the pressure chamber. However, once they were installed, they really required very little attention from us. As for the pressure chamber, you have to wrap 1 to 2 leaves per tree in a black plastic bag and then in foil 2 hours before you wanna measure. So the picture at the bottom, that is a leaf wrapped in foil, just to give you an idea of what that looks like. So we would go down and do this around 11 AM, and then at 1 PM, we would start using the pressure chamber to collect the data. That part took us about 45 minutes, and as I said before, we did this every 7 to 10 days. So that was the downside of the pressure chambers, that we didn't get as much data from that as we did the microtensiometers. You would only get the one data point the one day that you go down and wrap the leaves in foil. And then you wouldn't get another one until 7 to 10 days later when you went down and did it again. So this was the data that we got from June 10th through July 8th. And this graph shows us site 1, tree 1 and 2. So the green and the blue are the microtensiometer data, and then the black and the red dots are the pressure chamber data that we collected. That box represents one day. So the peak, which is about right in here, that represents the coolest temperature of the day. That's where the tree's the least stressed, and we found that to be around 6 AM. And then the lowest point, which was around here for both of those, that shows us the hottest temperature of the day, and we found that to usually be around 4 o'clock PM. So this shows us the water availability within the tree, which is related to how stressed the tree is. So as you can see, the second tree, which is the blue line, gets quite a bit more stressed right in here compared to the green line, which is tree 1. A good thing to this graph that we found was the black and the red dots, which were the pressure chamber data that we collected. They line up with the microtensiometer data, so that's really good. That shows that both of these are efficient and reliable. So for the environmental effect on stem water potential, we use the data that we collected from the microtensiometers, and we compared that to the vapor pressure deficit, which is a measurement related to temperature and relative humidity. So the bottom part of this graph on your right is the same as the graph that you saw before. So the orange and the gray lines represents tree 1 and 2 from site 1, and that's the microtensiometer data. And then the VPD is shown in blue above. So as you can see, as the VPD increases, that's where we see a decrease in the peak for both trees 1 and 2. Specifically, tree 2 was quite a bit more stressed, and that just shows that both of those trees did not have enough water, so they weren't as active during that time. So for our results, we found that the stormwater potential can be used to determine watering schedules and the amount of water that needs to be applied. And then we also determined that both the microtensiometer and the pressure chamber are reliable. However, the pressure chamber cannot be used regularly to monitor the tree like the microtensiometers can, because you cannot collect as much data as often as the microtensiometers. Thank you, and if you have any questions, please let me know.